Hello, good morning students. Today we are going to discuss the topic on probability theory for generative models from the course Generative AI and Agentic Systems. Let us start with the ice-breaking questions with a recap. Is artificial intelligence about prediction or probability? Let's take an example of tossing a coin. With this experiment we can find how many times the coin makes the tail and how many times the coin makes head. So with understanding of this uncertainty in generating the tail or head, so we can find the likelihood and the probability. So the 50% of chances would be tail and another 50% chance would be head. So here the applications of probability, it is applied in data science, AI predictions and decision making. So this quantification of uncertainty decides the likelihood of the the possibility of the particular event. So here the session objectives are to understand the probability foundations for the generative AI, also to explain the probabilistic generative paradigms in order to build an intuition behind the generative behavior, how we are going to explore the applications and the future of the applications usage. So let's take an example of cricket match. So this cricket match situation, if any rain, it interprets, okay, how the match results would be, whether the match would be completely cancelled or the if it is an ongoing match, how the how the score or the run rate would be revised. So this is one kind of example for the probabilitics reasoning. And with the problem statement, let's take a persona of a particular student, AI student Ananya. She's struggling to connect the probability with the models. So she needs to understand the difference between the GANs and VAEs, but she had a problem with the mathematics understanding. So as we know that GANs, generative adversarial networks, which is a combination of generators and discriminator, and VAEs is actually understood as variable automatic encoders. So if Ananya gets an understanding about how these GANs and VAEs are functioning, she can be able to apply the mathematics with that. And with the empathization using the design thinking approach, she thinks the probability is an abstract and people feels very much anxious about the equations and how this mathematics can be easily solved or derivated. And also she needs to have an intuition with the first explanation itself. So here to model a complex system or to enhance the AI performance, the student, Ananya, or any people have to understand the uncertainty first, and with uncertainty, likelihood and probability and the knowledge of statistics, we can have a predicting outcomes. So here the ideation stage and definition stage, let's take a challenge of finding the probability. So why the probability it matters in machine learning? Let's take within visuals and real world examples. We need to map the probability concepts to models. So here is a pictorial representation of population of all possible data. From the population, the sample data is being collected, and the collected data will be applied to the particular probability model with some inferences, and that will be applied to the exploratory data analysis that will help to build the models and predicting the behavior and the outcomes. So here the generative AI, as you see that we have that different steps and various phases. Here you can see that generative models, it's are learning from the distributions, and each variables, like whether it is in column variable, male and female, and the row variables are subjects like English and mathematics. So here we have three types of probability. One is joint probability, and the second one is marginal probability, and the third one is like conditional probability. So here we go that in three probability cases, we can have the combination of the subjects and the gender. So that's what it is given. The examples of joint probability and marginal probability and also the conditional probabilities are illustrated in this example. So here the core probability concepts are, you can take from the outcomes, events and the sample space. All possible outcomes are samples, and the samples have been taken from the events of subsets. So the likelihood of the observed data, which helps in sampling process, and that will create the new data points. So let's close the session with a wind up activity of think group solve. You take a scenario of handwritten digit, okay, and here we have four sampling, simple random sampling. The second one is systematic sampling, and the third one stratified sampling, and the fourth one is cluster sampling. So you have to identify the randomness through the learning of the samples, and also you need to discuss how these samplings generating the images. And finally, we came to know the three different probabilistic generative paradigms like VAEs, which is explicitly a probability model, and GANs are implicit probability learning model, and LLMs are auto-regressive probability model. So yes, the applications of the modern generative AI, it is used with the KL divergence and likelihood estimation process and entropy encoding and cross entropy encoding. Also Monte Carlo sampling, it's all applied with that. So here, we can see an example of the probability percentage. The forest is filled with the sound of singing birds, and if it is filled with the sound of singing of children, 25%, and the same forest is filled with of some other sorents, and that will be 10%. So here, these are the three different cases here, and the applications here, as per Stanford T model, it is applied in likelihood, healthcare, finance, and probability, risk management and medical diagnosis, and weather forecasting, and sports betting. So here the summary, the different types of distributions are used in the probability distribution: uniform distribution, exponential, binomial, geometry, and hypergeometry, and normal. Yes, the final assessments, which probability is most intuitive, and you have to give a short answers why the sampling is important, and for the multiple choice questions, why the KL divergence measures what. So thank you students, let us continue in the next class.